Hello, and welcome to today's lesson on generating sequences from the nth term. To begin with, without a calculator, can you complete as much of the following substitution spider without using a calculator? On your marks, get set, go. For today's learning objectives, we're going to start by being able to find a term given its position in a sequence. We're then going to be looking at generating sequences with positive integers given the nth term, and then generating sequences with negative integers given the nth term. This all comes in handy because there are lots of things in real life that form sequences, including when an embryo is developing in the womb. The number of cells it contains forms a sequence. Have a look at the sequence on the board. I've got the numbers 4, 7, 10, 13 and 16. Now, using what we call the term-to-term rule, I could say I'm adding 3 because 4 plus 3 is 7, 7 plus 3 is 10 and so on and so forth. Sometimes though, I don't know the previous terms and it's more helpful to look at the position-to-term rule. Now the position is just the number it is in the order of the sequence. So for example, 4 is position 1, 7 is position 2, 10 is position 3, for example. Now the rule for this sequence, when I'm looking at the position to term rule, is multiply by 3, then add 1. So if you look, 1 times 3 is 3, add 1 is 4. 2 times 3 is 6, add 1 is 7. Writing that algebraically is called the nth term. And for this sequence, I would write 3n, because that's how I write multiply by 3, and then add 1 at the end. Let's take a look at an example. Here is the nth term, 4n plus 3. As a reminder, that's telling me to do 4 times my position plus 3. So when n equals 1, I'd have 4 times 1, which is 4, plus 3 equals 7. When n equals 2, I'd have 4 times 2, which is 8, plus 3, which is 11. When n equals 3, 4 times 3 is 12, plus 3 is 15. I can do the same for the fourth term and the same for the fifth term, remembering at all times to use BIDMAS, which tells me I must multiply before I do the addition. That then generates the first 5 terms of this sequence as 7, 11, 15, 19 and 23. Now it's your turn. Using the example that we just did, can you generate the first 5 terms of these sequences, remembering to use BIDMAS? Pause the video here to give these questions a go. Okay, so when my nth term is n plus 5, substituting in 1, I'd have 1 plus 5, which is 6, 2 plus 5, 7, 3 plus 5, 8, 4 plus 5, 9, 5 plus 5, 10. With my second question, 6n tells me I need to multiply my position numbers by 6. So I'd have 6 times 1, which is 6, 6 times 2, 12, 6 times 3, 18, 6 times 4, 24, 6 times 5, 30. Moving on to one a little bit more complicated, I've got 7n minus 3 as my nth term. That tells me I need to do 7 times my position number minus 3 when I'm finished. So I've got 7 times 1, which is 7, take away the 3, which is 4. 7 times 2, 14, minus the 3, 11. Doing the same thing for the third term, I get 18. For the fourth term, I get 25. And for the fifth term, I get 32. This last one is a stretch because, as you can see, I'm now timesing by a negative. So I need to do 9, take away 2 times my position number. Working slowly through this. 9 minus 2 times 1 is the same as 9 take away 2, which is the same as 7. 9 minus 2 times 2 is the same as 9 take away 4, which is 5. 9 minus 2 times 3 is the same as 9 minus 6, which gives me an answer of 3. 9 minus 2 times 4 is the same as 9 minus 8, which is 1. And finally, 9 minus 2 times 5 is the same as 9 minus 10, which gives me an answer of minus 1. Time for a main task. All I need you to do in your book is write down the nth term of the sequences and then tell me what the first 5 terms in each sequence are. Please don't forget to use BIDMAS. There is an example on the slide to help you as well in terms of how to set your work out. The challenge is also on the board, looking at a sequence of dots and filling in a table. Good luck!